Good morning, grade 8. I hope you are all fine. Today we are going to learn about Newton's third law. I'm sure you know about it because we have done a lot of projects and presentations, but we will see it together again. So, Newton's third law states that for every action, there's an equal and opposite reaction. What does this mean? It means that for every force acting on an object, there's an equal force acting in the opposite direction. Think about it. What happens if you are standing on a skateboard and push against a wall? You slide in the opposite direction. It means away from the wall because you pushed on the wall, but the wall pushed back on you with equal and opposite force. Why does it hurt so much when you stub your toe? When your toe exerts a force on a rock, the rock exerts an equal force back on your toe. The harder you hit your toe against it, the more force the rock exerts back on your toe, and the more your toe will hurt. According to Newton, whenever objects A and B interact with each other, they exert forces upon each other. When you sit in your chair, your body exerts a downward force on the chair, and the chair exerts an upward force on your body. There are two forces resulting from this interaction, a force on the chair and a force on your body. These two forces are called action and reaction forces. For every action, there's an equal but opposite reaction. As you can see in this figure, I have a book on a table. The action is the force exerted by Earth on the book, and it goes downward. The reaction is the table's reaction to the book, which goes upward. They are equal in magnitude but opposite in direction. If you consider the birds, how do they fly? Flying through the air, the birds will depend on Newton's third law of motion. The birds push down on the air with their wings. In turn, the air reacts by pushing the birds upwards. The size of the force on the air equals the size of the force on the bird, but the direction of the force on the air, which is downward, is opposite to the direction of the force on the bird, which is upwards. Action and reaction, force pairs, make it possible for birds to fly. As you can see in this figure, the person is trying to push this object. The force is going right. The object makes a reaction to this person, which is left. They are equal in magnitude but in opposite direction. When an object sits on a surface, such as a tabletop, it is subject to two forces, the downward force of gravity and the upward force exerted by the table. As you can see in this figure, I have this object on the table. W is the gravity going down, N is the reaction of the table going up. Action and reaction. This is a very important question. Most of the students ask it. Why, since they are equal but opposite, why they don't cancel each other? If action and reaction force pairs are equal and opposite, how can anything move? Won't the action and reaction forces cancel? The answer is no. They don't cancel because each one of them is acting on a different object. Forces can cancel only if they act on the same object. In our case, each force is acting on a different object. This is why they don't cancel. This is another example of the third law. The motion of the rocket is an application of the third law of motion, because when fuels are burned in the engine, hot gases are produced. The hot gases push against the inside tube of the rocket and escape out of the bottom of the tube. As the gases move downward, the rocket moves in the opposite direction. So in our case here, this is the rocket. The action is rocket pushes on gases. The reaction is gases push on rocket. And this is also another example of Newton's third law. Consider the propulsion of a fish through the water. The fish pushes water backwards. In turn, the water reacts by pushing the fish forwards, through the water. So the size of the force on the water equals the size of the force on the fish. And the direction is always opposite. The force on the water is backward and the force on the fish is forward. Okay, let's consider I have a bug with a mass of 5 grams. It's flying into the windshield of a moving 1,000 kilogram bus. The question is, which will have the most force? The bug on the bus or the bus on the bug? Well, the answer is the force would be the same, which is surprising. But in fact, we have learned in Newton's second law that the force equals the mass times the acceleration. In case of the bug, we have a very small mass but a huge acceleration, while in the force applied by the bus, the mass is huge but the acceleration is very small. Both of them are equal. One of them is the reaction to the other. They are equal but opposite in direction. Now we will move to the momentum. The momentum is the measure of how hard or difficult it is to stop an object. This depends on the object's mass and velocity. The momentum is equal to mass times velocity, m, and v. M is in kilogram, velocity is in meters per second. According to this equation, momentum can increase if the mass increases or if the velocity increases. So if any of these two increases, the momentum is going to increase. The train has a large momentum because of its mass. The bullet fired also has a large momentum, though its mass is really small, but it has a very high velocity. This is why it will have a very huge momentum. Let's calculate a momentum. Example, calculate the momentum of a 14 bike traveling with a velocity of 2 meters per second. Momentum equals m, which is the mass, times v, which is the velocity. So it's 14 times 2 equals to 28. The unit is kilogram meter per second. Kilogram from the mass, meters per second from the velocity. And the last part of our lesson is the conservation of momentum. The total momentum of any group of objects remains the same unless outside forces act on the objects. If one object loses momentum, then another object must gain momentum. So momentum is always conserved. The law of conservation of the momentum states that the total momentum of objects that collide with each other is the same before and after the collision. Example, if you ever play billiards, when the cue ball hits another ball, the motion of both balls will change. The cue ball slows down and may change the direction, so its momentum is going to decrease. Meanwhile, other balls are going to start moving, so their momentum is going to increase. It seems as if the momentum is transferred from the cue ball to other balls. So the total momentum of 2 billiard balls before they hit and after they hit must be the same. Individual momentum can change even though total momentum remains. Example, if one ball speeds up after they hit, the other must slow down. As you can see in this picture, I have 5 balls. 4 of them are at rest and 1 is being pushed by this person. What's going to happen now is the 4 first ball are going to become at rest and the last ball is going to move, as if the motion of the first ball after hitting the 4 ball is transferred to the last one. This is approximately the same example, but this time this girl is moving 2 balls. It's pushing 2 balls. After pushing these 2 balls, I will have 2 balls that are moving in the end. And in this picture also, I have 4 balls. 4 balls that are moving and 1 ball that is not moving. and has a momentum equals to 0. So the total momentum of the system is the mass of the first four times their velocity. After they hit each other, one of the four balls are not going to move anymore, and I will have four other balls moving, which means that the momentum has been transferred from the first object, which were the first four balls, to another object. Example: the momentum of a baseball bat is transferred to the ball when the bat and the ball meet. The act of throwing an object off a boat causes the boat to move in the opposite direction. The more massive the object and the faster it is thrown, the faster the boat will move away. And finally, let's remember the Newton's laws of motion. The first law states that an object at rest will stay at rest, and an object in motion will stay in motion at a constant velocity unless acted upon by an unbalanced force. The second law states that force equals mass times acceleration, F equals ma. And the third and last law states that for every action there is an equal and opposite reaction. Thank you very much.